Alright, we're going to be going over the different parent functions that we're going to be studying in class for this next unit. I recommend that you pause the video at different moments to just copy down the graph, the name, and the equation, because that's what's important here. In class on Monday, we'll focus on how to exactly figure this stuff out and calculate it and all, but for now we're just sketching these. So looking at the first one, it's quadratic, and the formula for the quadratic parent function is f of x equals x squared. Some of you are probably already thinking, f of x, I don't understand what that means. F of x means the exact same thing as y, so these both are the exact same thing. Why do we use f of x? That's for a totally different discussion, but you're going to see me write f of x instead of y. Just get over it. But then here you see the picture, and it's just a parabola. So sketch that down, and then carry on. Square root parent function is f of x equals square root of x. And it kind of is a little bit similar to how the quadratic one looked, only it's sideways and we only see half of it. And there's a reason for that. Again, something we'll talk about much later in the year. Again, sketch that picture there for the square root function. Absolute value is V-shaped, absolute value V-shaped, and absolute value, when you write it, it has these little bars around it, and so again, it's a V-shaped graph because absolute value is V-shaped. Now here's a little bit of a different one. Rational parent function. For rational, think ratio, fraction. So fraction, there's your little fraction, f of x equals 1 over x. And the way that this one looks, it doesn't go through the origin. It's one of the few that does not go through the origin. And it has asymptotes. So you see here on the left-hand side, this is kind of flattening out toward the x-axis, the negative x-axis. That's an asymptote. And then you get closer to the origin, it starts to go down, and it's flattening toward the y-axis. Again, an asymptote. And then on the other hand, the other side here, we see the exact same thing, just it's on the top now. So again, an asymptote flattening out from the y-axis and then flattening out toward the x-axis. It never touches any axis ever. But that is the rational parent function. Also having an asymptote is the exponential function. Now, exponential just means that the exponent is an x, but the base could be anything. We're going to use 2 because that's the simplest one. I guess now's a good time to mention that parent function just means the simplest version of that function, meaning there's nothing else going on in it. It's just the bare bones of what an exponential looks like, or the bare bones of what a rational or quadratic or whatever looks like. So it just has the absolute minimum necessary to still look like that type of function. Okay, so an exponential function, like I said, f of x equals 2 to the x power. The x is the exponent. What it looks like here is an asymptote on the x-axis, and then it just starts to really drastically rise like that. Then, let's see here. Then we've got logarithmic. Logarithmic. And abbreviated, we just call it log. And we'll talk about logs much later in the year, but log, parent function, is f of x equals log x. Okay? And it looks kind of similar to your exponential, only the asymptote is on the y-axis, so it's flattening out from there. Then it passes through 1, 0, and then it starts to really flatten out. It doesn't asymptote flat out, it just gets really, it rises extremely slowly. Make sure you're sketching these. Okay. Cubic. You know, I didn't do a good job of writing this one. I'm going to do that again. Okay. So cubic is f of x equals x cubed, and it's kind of similar to the way that a quadratic looks on the right-hand side, but then the left-hand side it flips and goes the other way. So sketch that. And then lastly, cube root here. We're actually going to go through the process right now of how do you sketch this if you don't just automatically know it like a math teacher here. And the way you do that really is you make a table by knowing how to calculate the values. So let's first of all say, of course, cube root what does that equation look like? Cube root, huh? I know square root. Well, cube root is like a square root, only you put a number in the top corner here to show that it's a cube root. And so I'm going to put a 3 here in the corner of that square root symbol, and now that means we're doing a cube root. And then now how we draw this thing is we make a table, first of all, x and y table, and we're going to have to think of numbers that you can perfectly cube root. And again, cubing just means a number times itself, so that's 3 times. And an easy one to start with would be 0. The cube root of 0 is still 0 because 0 times 0 times 0 is 0. So I can graph 0, 0. That's a given. And then I know that the next cube number is 1 because 1 times 1 times 1 is still 1. But if I try to go to the next number, if I try to go 0, 1, 2 for x's, well, there isn't a number, and a whole number, times itself, times itself, times itself, that's 2. That doesn't work. But if I did that on the y's, I could actually think about it. 2 times 2 times 2 is 8, so the cube root of 8 is 2. And we can graph that then. X value is 8, y value is 2. And that's all we're going to get to fit on this one, on this side of it here. But we can go to the negatives as well. And if you see the pattern here on the y's, I was going 0, 1, 2. So if I go backwards, the next number would be -1. And we think -1 times -1 times -1 is still -1. So graph that point, and then you might have guessed it, that -8 is the last cube root number, and the cube root of -8 is -2. So graph that one, and sketch through those points. And you'll notice that this looks very similar to the cubic, but just kind of turned sideways. All right, and we'll focus more on this on Monday in class. Make sure that you have all of these sketched with the names and the equations. See you on Monday.